Performance analysis of solar PV model. That is VI and PV characteristics. And so by using VI and PV characteristics of solar PV cell, we can understand the performance analysis. So, okay. So this is called construction of solar cell. The solar cell is having N-type silicon plate and also P-type silicon plate. There are two types of plates, N-type silicon plate and the P-type silicon plate. In between, there is a depletion layer present. Okay, and it's having two metallic conducting strips. This is called one metallic conducting strips, and this is also another metallic conducting strips. By using this metallic conducting strips, the current can be collected. And when the solar radiation, that is called photolight, falling on this solar cell, the electrons emitted from this solar cell, and this flow of free electrons in this direction, that is called current. Okay, so this is called here negative electrons in the upper plate. This is called N-type silicon is having negative electrons, and P-type silicon is having holes, positive holes. Holes are called positive, electrons is called negative. Okay, so then this is called PV cell symbol, representation of the PV cell symbol. And this is some construction regarding about solar PV cell. And then coming to the next characteristics of typical IV characteristics of IV characteristics of solar PV cell, and also power versus curve, power versus voltage curve of solar PV cell. This is called current versus voltage curve of solar PV cell. The y-axis called voltage, x-axis called voltage, y-axis called current. So current versus voltage characteristics of PV cell changes like this. Okay, so this is called short circuit current, maximum current initially. Then when the voltage increases, the current is decreasing. This is called IV characteristics, current versus voltage characteristics of PV cell. And the next power versus voltage characteristics of this PV cell is called just like this, exponential, linearly is increasing like this. The power versus voltage, this is called power and this is called voltage. Then power versus voltage is increasing like this. Okay, here there is a maximum power point. This point is called maximum power point. So these are the called characteristics, IV characteristics of solar PV cell and the PV characteristics of solar PV cell. Here, short circuit current, maximum current initially when voltage 0, maximum current. That's okay. Then voltage is maximum, open circuit voltage, the current is minimum. Okay, so this point is called maximum power point, operating maximum power point. Okay, so this is the IV and PV characteristics of solar PV cell. Then next, what are the parameters in solar PV cell? Means the parallel strings is called 1. In this design of solar PV cell, I am choosing like this, parallel strings are 1. Okay, and a series connected modular per string is called 1. Only one parallel string and the series connected module per string is called 1 only. Okay, here 1, here 1. So corresponding this parallel strings and a series connected module per string is 1 is nothing but these are the parameters. That is called maximum power rating is called 213.15. And the cell per module is called 60. And then open circuit voltage VOC is called 36.3. Open circuit voltage is called 36.3 volts. Okay. And next short circuit current ISC is called 7.8. Maximum value of current, short circuit current is called 7.84 amps. And maximum value of open circuit voltage is called 36.3 volts. And then voltage at which the maximum power point, voltage is nothing but 29 volts. At 29 volts, the maximum power point we can observe from the IV characteristics and PV characteristics of solar cell. And then current at maximum power point is nothing but 7.35. At voltage 29 volts, the maximum power, and at current of 7.35, the maximum power point can be identified by using IV and PV characteristics of solar PV cell. And next, temperature coefficient VOC, percentage degrees Celsius, it's called minus 0.36099. And temperature coefficient for ISC, percentage in degrees for 0.102. So these are the different types of parameters of solar PV cell for design of parallel string 1 and series connected modules for string 1. For this, these are the different types of parameters. Okay. And the next, this is the circuit diagram of solar PV cell. In this solar PV cell, this is called solar PV array. So by taking the one solar PV array, so we have to find the characteristics, IV characteristics here, XY graph. This is connected to the current. X is called here voltage. X-axis called voltage. Y-axis called current. That's why here we will get IV characteristics. X-axis is voltage. Y-axis called current. That is nothing but IV characteristics. Current measurement used to measure the current. And next XY graph 1, by using this power versus voltage characteristics. Here X-axis called like here, this product of voltage and current is called power, and current is called y-axis called voltage. Understood? Then next, this is called current measurement, and this is called controlled voltage source. By using this, voltage can be controlled, and by changing the repeating sequence, by using with the help of repeating sequence, and this is called voltage measurement, and this is called irradiance. IR is called irradiance. Generally, for solar light, irradiance is generally 1000 watts per meter square, and temperature, this is called temperature 25 degrees Celsius. So these are the parameters we have to take, components we have to take for design of solar PV model. Okay. And then next, by using efficiency, we can find the performance characteristics of solar PV cell by using this fill factor FF. If it value I means better quality of cell. Fill factor is I, then quality of the cell is I. That fill factor is nothing but P maximum divided by Vs into VO, Is into VOC. The P maximum is equal Im into Vm by Is into VOC. So this is the formula for fill factor. The value of fill factor between 0.98 to 0.9. And then calculation of efficiency by using fill factor. So efficiency is nothing but output electrical energy per second by incidence light per energy per second. Here that is called P maximum by P in, VSC into VOC into FF. That is called fill factor by P in. So then fill factor is equal to P maximum by Is into VOC. Then P maximum is equal to Is into VOC into FF. By substituting here, P maximum is equal. This is the formula. Is into VOC into FF divided by P in. Power input. Then next one, by taking the one example, you can understand how to calculate the efficiency. Let for a solar cell having short circuit current of 350 amps per meter square and open circuit voltage 0.6 volts and fill factor is called 0.8. The irradiance value for P input, that is called 1000 watts per meter square. Input power is nothing but that is called irradiance. This is from sunlight. We will get this power is nothing but 1000 watts per meter square. Then efficiency is called output per input. Output is nothing but ISC into VOC into FF by P input. ISC is called 350, VOC 0.6, 0.8 by multiplying and this, and then by substituting these values P in and here, and then we will get efficiency approximately 17%. So this is the one calculation of solar PV cell for efficiency calculation. And then let's go for a design of solar PV cell by using MATLAB. And then here, so open MATLAB, press home and Simulink, press Simulink and go to create module, press create module, and then it will be new window of shows like this. And from this library browser, we can take the elements. So from this library browser, enter here PV array. Okay, and press. So this is called PV array. Add to untitled block model. Okay. So PV array can be added like this. This is called PV array, solar PV array. The IR is called irradiance, T is called temperature, M is called, here we have to connect one measurement. This is used to measurement. From this, we have to connect one bus selector. By using bus selector, we can measure the current to voltage like this, and this is called positive and negative terminals of the solar PV cell. Understood? So in this solar PV cell, first this irradiance we have to connect by taking one step input. Step. Enter here, right here, step. The irradiance is changing from 0 to 1000 watts per meter square. Maximum level of irradiance is called 1000 watts per meter square. That's why I'm changing initial value is called 0.01 and finally 1000. Okay, initial value is called 0.01 and final value is called 1000. Then apply. Okay. This is called irradiance. The next element, this is called temperature. So by taking one constant, right here, constant, temperature approximately for solar PV cell, let us take 25 degrees Celsius. Like 25. Apply. Okay. This is called irradiance, and this is called temperature. And next, current to voltage. What is the according to circuit diagram? And the current measurement and voltage controlled voltage source is required. Okay, controlled voltage source is required. Current measurement and controlled voltage source. Right here, controlled voltage source. Controlled voltage source. Controlled voltage source. Controlled voltage source. So this is our controlled voltage source. Okay. Controlled voltage source right here. The controlled voltage source is having positive and negative terminals. So in between these two, we have to connect one current measurement. Connect one current measurement. Take right here, current measurement. Current measurement. Place here, current measurement. Connect positive to positive of current measurement. And a negative to negative of O. Connect here like this, as per circuit diagram. Current positive terminal here, and a negative terminal is connected here. Positive terminal of control voltage source. And next negative terminal connect to here. Negative terminal connect a negative terminal of solar PV. Okay. And take one repeating sequence. Repeating REAP. Repeating sequence. REPEATING. Repeating sequence. Take this like this. So repeating sequence, connect here. So repeating sequence to change the voltage, to control the voltage, to change the voltage of this voltage controlled controlled voltage source, then we have to use here. And then here, so according to our what is that requirement circuit diagram, parameters according to our parameters. So what is the first one? Parallel strings are 1 and a series connected module per string is called 1. Parallel string is called 1. We have to change like this. So open this solar PV array. Here, change the settings. Right here, instead of 40, 1 parallel strings is 1 and the series connected modules per string is called 1. So corresponding by changing this 1, parallel strings 1 and a series connected strings 1, then open circuit voltage. These are the parameters. Maximum power is called 213.15. By default, it is calculated like this. And the cell per module is called 60. And open circuit voltage is called 36.3. Here, open circuit voltage is called 36.3. That's why this 36.3 we have to use in repeating sequence of maximum value. And then short circuit current is 7.84. Okay. So remember, open circuit voltage is how much? 36.3. Then okay, apply. And then open repeating sequence. Here, right, enter right here. 0, 1, 2. For 0, 1, 2, repeating sequence is changing like this. First one 0, it's starting from 0, and then it is increases to 36.3, 36.3, and then it is 0. Like this, it is changes, repeating sequence is changes. This voltage, maximum voltage is called 36.3. Then apply, okay. So then next current measurement is over, and here we have to connect one XY graph current to get IV characteristics. XY graph you have to take. First, select one voltage measurement, take one voltage measurement, and then like this, connect exactly parallel to the controlled voltage source. Yeah, in this way, connect parallel. So this is called, what is this? Voltage measurement, just like voltmeter. And this current measurement, current and IV characteristics. To get IV characteristics, voltage on x-axis, current on y-axis. So take one XY graph, right here, XY graph, Simulink graph, XY graph. Here XY graph, X is called current, X is called, what is this? X voltage. X-axis is called voltage, and y-axis is called current. Like this. This is first graph is called IV characteristics. And then similarly, PV characteristics. To get PV characteristics, first we have to multiply voltage and current. That's why take product, right? Product here. So take product. That means voltage and current. This is called voltage and current. Like this, connect. Here voltage, here from voltage measurement, we have to take voltage, and current measurement, current, and then product. That is called power is equal V into I. So power is on y-axis. Power is on y-axis. Voltage on x-axis. Like this. This is called voltage on x-axis, and the current is y-axis. Here also x-axis called voltage. X-axis called voltage. Here also x-axis voltage. Common x-axis, but power changes. Power here, power on y-axis, here current on y-axis. So like this, this circuit solar PV model is designed, and then simulate. Take one power guy, right here, power guy, place here, power guy. Take power guy and place here. Okay, and then simulate. It's compiling, it takes some time. After compiling, open XY graph. Press here we will get XY graph, IV characteristics of solar PV cell. IV characteristics of solar PV without any modifications, directly will be adjusted XY graph. It will be show current versus voltage characteristics. This is called IV characteristics of solar PV model. Okay. So short circuit current approximately 7.8 like this. So from this here, this is called IV characteristics of solar PV model. So voltage is called 36.3. So that's why maximum voltage up to here we will get the characteristics of solar PV model. And then coming to the, this is called IV characteristics, current versus voltage characteristics. Then coming to the PV characteristics, so power versus voltage characteristics. Open this PV characteristics of solar PV model, and then it's linearly it's increasing. Press this. Step input to 0.01 and final initial value 0. Step is called 0.01. Final value is called 1000. Initial value 0 and step is called 0.01. Okay, step time is called 0.01. Final value is 1000. Change like this. Initial 0, final value 1000. And then simulate. By simulating across this XY graph, so we will get, this is called IV characteristics, current versus voltage characteristics of solar PV model. Like this, you can understand. So short circuit current is called 8 Open circuit voltage is called 36.3. So like this, we will can understand the IV characteristics of solar PV cell. Okay, and then coming to the PV characteristics of solar PV cell, the XY graph 1, open this XY graph 1, PV characteristics of solar cell. Power versus voltage characteristics. Like this, the power versus voltage characteristics of solar cell is changes like this. So here power is, what is the voltage here? Maximum voltage is at 27 volts. Maximum power tracking voltage is called according when solar cell is open PV array, solar PV cell model. And then here, what is the maximum power? At maximum power point is called 29 volts. The current is called 7.35. At maximum power point, at 213, this is called maximum power is called 213 watts. Corresponding 29 volts and 7.35 is called power, maximum power. That power you can identify by using this figure here. 213 here, 210, and then 213 here. This we will get maximum power. And what is the voltage? 29 volts. And what is the current? Is nothing but 7. Okay, this is called power versus voltage characteristics. Here voltage is called 29 volts. Corresponding 29 volts, we will get maximum power, that is called 213. 210 means here approximately this is called maximum power point track at point. So this is called PV characteristics of solar PV model. Like this, by connecting the circuit as per circuit diagram, and then we can understand the IV and PV characteristics of solar cell. Understood? So this is the circuit diagram. In this way we have to connect solar PV cell. Solar PV array step, that is called irradiance. Here IR is called irradiance, temperature and measurement, connecting terminals and positive and negative. This is connected to the current measurement, controlled voltage source, voltage measurement and repeating sequence and product of current and voltage. That is called power. And like this, we can connect the circuit. Okay, this is about a solar PV cell.